We are given the following problem. If a plus b is equal to 12 and a times b is equal to 8, then what is a squared plus b squared? When we first approach this problem, we don't actually want to know what a plus b, what a is equal to, or we don't want to solve for the variables a and b. What we actually want to do is the following. So first we want to write the problem out. So we plus b is equal to 12, and a times b is equal to 8. Now, we can solve this problem by first just realizing that if we do a plus b in parentheses, so that means we want to solve for a plus b first, and then we'll have to square it. Well, this would be equivalent to a squared plus 2ab plus b squared. Now, given this, we can say, okay, we know what is a plus b? Well, we know a plus b is equal to 12. So we'll substitute a plus b, so we'll put 12 in for a plus b, and we'll square that is equal to. Now we can also say, well, we want to take a look at ab. Well, ab is equal to just a times b, so basically we want to say, okay, now what if we multiply both sides by 2, so therefore 2ab, sorry about my writing there, 2ab is equal to 16. So we'll take this 16 and a squared plus b squared, let me just make that more like a 1, is equal, so plus b squared. So now what is 12 times 12? Well, that would be 144, equal to a squared plus 16 plus b squared. Now, and as you may have learned in algebra, we want to make both of these sides even. So, in order to make them even, we must subtract 16 from both sides, so that we are just given 128 is equal to a squared plus b squared, and that's it. Because as I said before, we don't want to solve for a and b, because we just want to know what is a squared plus b squared. Alright, moving on to our next problem. We want to solve for x. If 7 to the 48th power minus 7 to the 47th power minus 7 to the 46th power divided by 41 is equal to 7 to the xth power, we want to solve for x. So, we first approach this problem by saying, okay, how can I rewrite 7 to the 48th power minus 7, oh, that's a 4, 7, and let me just redo that, 7 to the 47th power. Well, we can rewrite this. Well, here's a fun fact. When we write this, what I did first off is what is 7 squared minus 7 to the first? Well, that would be 42. And how can we write this in terms where we have this, where we have 7? Let's divide this by 7. Well, it would be 6, because we would take a 7 from it. So therefore, we're left with 7 to the second power minus 7 to the first power is equal to 7 times 6. Now, Let's just back up and erase all that real quick. Now we can use this logic to help us solve this problem. So we can say, okay, so while doing this, we can simplify this as 6 times 7 to the 47th power. Alright, so now we'll have to substitute it. So 6 times 7 to the 47th power minus 7 to the 46th power is equal, well, divided by 41 is equal to 7 to the x power. Now, from here, what we want to do is we want to use the same logic. However, let's just take a look at 5, 7 to the 47th. Oh, wait. So 5 times 7th. Because we don't know. We want to solve for if, okay. Yeah. So just take 5 of these. So now it's just 7. Like, hold on to these for later. So now it'll just be 7 to the 47th power minus 7 to the 46th power. This will help us solve for basically how we can express this. So we know if we multiply this by 7, this will just get us 7 to the 47th power. So if we just subtract 1, 7 to the 46th, using the logic we used in the previous example, this would be 6 times 7 to the 46th power. Sorry about the bad handwriting. Now, this time, let's go back to the 5 times the 7 over 47. How could we rewrite that as, we'll have, what will we multiply by 7 over 46? That's right, we'll do 7 times 5, so 35. So 35 times 7 to the 46th power is equal to 5 times the 7 to the 47th power. So now, because we are multiplying these two by the same number, let's just take out 2. Oh, yeah. Let's take these two. We can add them up since we can add these up together. So that would give us 41 times 7 to the 46th power, which divided by 41 will have to equal 7 to the x power. Now we want to solve for x, they'll remember that. So we can just cross out 41 on both sides, which now we are left with 7 over x is equal to 7 over 46. And since we want to just solve for x here, we can just cross out these and have x equal 46. And voila, there's our answer. Okay, moving into down to our final problem of the day. Let's see if I can find it. We want to find the units digit of 35 to the 78th power minus 34 to the 99th power. So, to start off, what we will do is we'll first go, okay, what is even the units digit? For those of you that are new to this understanding of what the units digit is, units digit would be this. So if I have the number 123, 3 is the units digit. Okay, now let's erase that. Okay, so how do we find 35 to the 78th power, you may ask? Well, we won't obviously multiply 35 by itself 78 times. Instead, we'll use a little bit of logic. So we know that if we multiply 5 by itself, no matter how many times, the units digit will always be 5. So we can have this be 5, or whatever. We know that this units digit will be 5 in this case. So now just keep that in mind for when we solve this next problem. So 34 to the 99th power. That can be quite intimidating. However, if we do the following, it can be a little easier. So what we know that we know that if we only want to focus on the units digit here really, so if we multiply these together, we know that it will end in a 6 because 4 times 4 is 16. No other number we do will basically interfere, so 6 will be the units digit always. But how about, so let's just focus on the 4 for now. So you want to focus on its units digit, and what would be 4 times 4, and you want to kind of notice a pattern per se. So 4 times 4 times 4, that would equal 64, because 4 times 4 is equal to 16 times 4, that would be 64. Now, what would be 4 times 4? This would be 16. And if you really want to do it, then 4 times 4 times 4 times 4, that would equal 256. And just to do this theory, now honestly you don't have to do this next step in the process if you don't want to, but I might recommend doing it, but you really don't have to. It's not really that useful, but so 4 times 4 times 4 times 4 times 4, this is equal to 1024. Now, if you don't notice the pattern by now, whenever we have like an like if we're doing 4 squared, whenever the exponent is even, it will end in a 6. Whenever it is odd, it will end in a 4. So using that, I believe we can safely assume that the units digit in this case will be a 4. So we'll take the 5 minus the 4, and therefore the units digit should, in theory, be 1. That's it for this video. Thank you for watching, and